one and all. Welcome to SRN Knowledge Centre. I am Purvi Mishra, Math faculty in SRN International School, Jaipur. The topic that I have chosen today is trigonometric waves. Waves are familiar to us from the ocean, the study of sound, earthquakes and other natural phenomena. To fully understand waves, we need to understand measurements associated with these waves. It is possible to look at waves mathematically because a wave's shape repeats itself over a consistent interval of time and distance. The mathematical equation representing the simplest wave looks like this: y is equals to sine x. This equation describes how a wave would be plotted on a graph stating that y is a function of sine of the number x. The sine function is one of the trigonometric ratios. The word trigonometry means measurement of triangles. Now let us come on trigonometric functions. The specific relationships between the angle measure and the sides of the triangle are what we call the trigonometric functions. These can be defined in relation to the unit circle. Unit circle is defined as a circle that has a radius equal to 1. First of all, let's take the sine function. In a triangle, it is defined as perpendicular or opposite side upon hypotenuse. Now consider a unit circle on the Cartesian plane with an inscribed triangle. The point on the circle touched by the radius has coordinates x, y. Now sine of A is defined as opposite upon hypotenuse, which is equal to opposite because value of hypotenuse is 1 here. So the sine of A gives the length of the opposite side of the triangle or the y coordinate on our Cartesian plane. Similarly, cosine of A will give us the x coordinate on the Cartesian plane. Now if we keep on drawing the triangle as we move counterclockwise on the circle, we can begin to see that the trigonometric functions, that is sine and cosine here, take on a periodic quality. Moving counterclockwise on the circle, we find that the sine function takes up the maximum value at 1, that is at the top of the circle. Then it begins to take negative values as we continue around the circle. It attains a minimum value at the bottom of the circle and then again moves upwards. Plotting a basic sine wave. When the sine of an angle is plotted against angle measure, the result is a classic sine wave shape. Please have a look at this video. As described earlier, as the point moves counterclockwise, we see a rise in the graph. As the point moves further, the graph falls. When talking in radians, the plot of sine waves starts with the point being at 0 position at 0 radians. Then it takes the value half at pi by 6, 1 by root 2 at pi by 4. Then it takes the value of root 3 by 2 at pi by 3. It takes the maximum value, that is 1, at pi by 2. And then it takes the value 0. Then it goes to minus 1 value, that is the minimum value at 3 pi by 2. And then it again takes the value 0 at 2 pi. This was all for today. If you found the information valuable, please like, share and subscribe my video. Thank you.